Welcome to Summarize Science. Today, we are exploring a massive leap in artificial intelligence called Qwen-VLA. This new research presents a unified model that can control different types of robots across many different environments. Traditionally, robots are like specialists that only know how to do one specific task in one specific place. One robot might be great at moving a cup on a table, while another is good at navigating a hallway, but they rarely share their skills. The researchers behind Qwen-VLA wanted to change that by creating a single brain for all of them. By combining vision, language, and action, this model allows a robot to understand a command and figure out the physical steps to complete it. It does not just see a picture, it understands the spatial relationships between objects. This allows it to perform perception, reasoning, and movement all within the same framework. One of the most interesting parts is that the model is told exactly what kind of robot it is controlling through a simple text prompt. If the robot has 2 arms or a mobile base, it adjusts its behavior automatically based on that description. This means the same software can potentially run on many different robot bodies without a complete redesign. To make this work, a unique 4-stage training process was used. It starts by learning the logic of physical actions from text alone before it is even shown a single image. This text-to-action phase builds a strong foundation for how movements should flow in a 3-dimensional space. Look at these examples where the robot is tasked with placing staplers or grouping drinks. The model can break down a long instruction like "clean the sponge" into several smaller, successful steps. It successfully bridges the gap between high-level human language and low-level motor controls. In real-world tests using a robot system called Aloha, the model showed incredible versatility. It successfully handled tasks ranging from stacking bowls in a specific color order to folding a towel. It even learned how to open drawers to place an object inside and then close it with high precision. Even more impressive is its ability to handle tasks it was never specifically trained for. In these tests, the robot could identify and grab a toy duck or a piece of broccoli it had never encountered in its training data. This suggests the model has a genuine understanding of the objects it interacts with. When compared to specialized AI models, this generalist model actually outperformed many of them in complex simulations. The data shows that learning a variety of tasks together makes the AI smarter and more adaptable than learning them one by one. It handles everything from navigation to fine-grained manipulation with consistent success. To recap, Qwen-VLA represents a shift from robots that follow rigid code to robots that understand our world through sight and language. It can adapt to new tools, new chores, and new surroundings on the fly without needing a human to reprogram it. This is a fundamental step toward building robots that can truly function in the messy real world. This could lead to a future where general-purpose home assistants are a reality. Instead of buying a new robot for every chore, one versatile machine could handle everything from cleaning to organization. Thanks for watching Summarize Science, and stay tuned for more breakthroughs in the world of technology.